Good morning, students. As you know, we have finished chapter 1 matter, so we quickly revise the chapter. Our chapter is matter. Now, what is matter? Matter is anything that has mass and occupies space. Then the main topic is kinetic theory of matter. This theory explains microscopic particles of matter. It also explains why does the matter exist in different states. Third, it helps to understand the properties of matter. Now, what are the different aspects, postulates of this theory? Number 1, matter is made up of tiny particles, that is atoms and molecules. Second is, there are empty spaces between particles of matter called intermolecular spaces. Third, there are attractive forces among these particles of matter called intermolecular forces. Fourth aspect is all the particles of matter are having kinetic energy that decides the state of matter. Number 5, the temperature of particles indicate the average kinetic energy of the molecules. Last postulate is a change in state may occur when the energy of particles change. So next is our change of states. Change of states, there are 3 states of matter: solid, liquid and gases. Solids, for example, rocks, wood, brick, etc. Then liquids, examples are water, petrol, diesel, milk, etc. And gases, for example, hydrogen, oxygen, nitrogen, etc. So all these are differentiated with the help of their characteristics, whether they should be solid, liquid or gases. And let us discuss what are these. The particles of matter, namely atom, molecule, are in this constant motion, that they are all having kinetic energy. Their interparticle force of attraction called force of cohesion between the particles. So these two factors, they also decide the state of matter in which they should be. Now first of all, let us do what is solid state. Solid state, the particles are very closely spaced. Movement is very less. Particles simply vibrate about their mean position. They cannot move far away. They have definite shape and definite volume. Solids are rigid. Then solids normally do not flow. Solids have high mass per unit volume. Solids have high boiling and melting point. Next stage is liquid state. Particles are loosely packed and interparticle spaces are larger than that of solids. The interparticle attractive forces are weaker than that of solids. Particles of liquid can move over short distances. They can readjust their position. Then liquids do not have definite shape. They have definite volume. Liquids can be slightly compressed. Liquids can flow. Liquids have lower mass per unit volume. Liquids have lower boiling point than that of solids. Then comes our gaseous states. From this activity you can see liquid take the shape of the container. If the volume is fixed, pour them in different containers, they will take the shape, but volume will not change. It means the liquid take the shape of the container in which they are poured, but the volume does not change. Then gaseous state. Particles are at a very larger distance from each other. Interparticle spaces are very much large. Practically no interparticle attractive forces is present among particles, are free to move at random, and then gases do not have definite volume or definite shape. Gases can flow easily. Gases can be highly compressed. Gases have low mass per unit volume. Then there is one activity to show that gases are highly compressible. In this activity, 3 syringes are taken. Their mouths are blocked with a rubber cork. In first it is air, second taken with water, and third chalk powder. And if we try to compress it, we won't be able to compress solid much, but we can compress gases much because there are large intermolecular spaces between them. Then comes energy content in states of matter. First of all, solid state. as we know that all the states of matter, all the particles, they have their kinetic energy. So solid state, the kinetic energy of particles, that is very low, because of, so they cannot flow. In liquid state, the kinetic energy is relatively high than that of solid. So kinetic energy particle is more than that of solid. So kinetic energy liquid increases with increase in temperature. Gaseous state, particles are loosely packed, interparticle forces are negligible, kinetic energy of the gas is very high, so they can easily flow in all the directions. Since liquids and gases can easily flow, they are known as fluids. There is one other experiment to demonstrate that different states of matter have different kinetic energy. So for that we have taken pieces of black chalks, duster, little quantity of milk, spoon, incense stick and matchbook. Duster, if you place it on a smooth surface, it will not move on its own. But chalks, they can roll down, that is due to their shape, but they cannot move at all. Now spill 2-3 spoons of milk, what will happen? It start flowing, but it will not to a larger distance. And burn an incense stick with matchstick, what will happen? Aroma of the incense stick spread in whole room quickly. So what is the result of this activity? That solid do not move as they have negligible kinetic energy. Liquids flow, so they have high kinetic energy than that of solids. And gases fill the available space quickly because they have very high kinetic energy. Next is one table that shows the comparison of these three states of matter on the basis of certain properties. Then change of state. Now change of state, that one state of matter can be changed into other. As an example is given, ice on heating changes to water, water on heating changes to steam, and on cooling steam changes to water, and water on cooling changes to ice again. Now what are the state of matter can be had by three factors: change in temperature, change in pressure, or changing both temperature and pressure. So we can change the state. Now change of state can be irreversible. That, as we have done here, on heating state changes, then on cooling it comes back into its state. So this is interconversion. Now during this change of state, there are some processes that occur. These processes are, the first one is vaporization. Vaporization is when a liquid is heated and it changes to a gas. That is known as vaporization. So it is change of state from liquid to gas on heating. And vapor is a gaseous state of substance. Vaporization can be of two types: boiling and evaporation. Boiling, form of vaporization, and it is quick vaporization when heated to boiling point. For example, boiling point of water is 100 degrees Celsius, right? So boiling, what is boiling point? It is the temperature at which liquid changes into vapor without any further increase in temperature. That is 1 atmospheric pressure. So pressure should be 1 atmosphere, and it is the temperature at which water starts boiling. What happens at particle level? That on heating, solid particles, they get energy and their forces weaken. As a result, they move away from each other and they come into the liquid state. Then different liquids have different boiling point, as you can see in this table, and boiling point increases with increase in pressure and impurities, right? You read these interesting facts on the way. And to demonstrate the evaporization of water, to find out the boiling occurs at a fixed temperature. This experiment, as we have discussed earlier also. So what we are going to do in this experiment, we will set apparatus in the lab like this. We take some water in the beaker, and thermometer will set with the help of a laboratory stand. We start heating the beaker and start noting the temperature. When the temperature reaches 100 degrees Celsius, the water start boiling, and the temperature remains 100 degree until the whole water changes into steam. And where does this additional heat goes then? This additional heat is known as latent heat of vaporization. It does not change the temperature, but it only helps in change of state. Evaporation is another form of vaporization. and it is a slow process. It is also a change of liquid state into gaseous, but at any temperature. So these clothes are drying due to evaporation, and there are difference between takes place at any temperature evaporation and boiling. It occurs at a fixed temperature. Evaporation causes cooling, boiling does not. Evaporation occurs at the surface of the liquid, but whereas boiling occurs throughout the liquid. Evaporation is a slow and silent process, whereas boiling is a rapid process. At particle level, what happens? The molecules, they gain heat from the surrounding and they start colliding with each other because their kinetic energy increase, and as a result the surface particles, they get more kinetic energy, they break their bonds and get free in the form of vapors. Then factors affecting evaporation. Temperature. Evaporation increases with increase in temperature. For example, wet clothes dry quickly on the sunshine. Then nature of the liquid. Nature, it means that different liquids, they evaporate at different temperature. A substance that evaporates easily and readily at normal temperature is called volatile. So liquids like alcohol, ether, chloroform, these are volatile. Then third factor is surface area. Evaporation increases, the rate of evaporation increases when the area increases. For example, if you spread or hang them, your clothes, they will dry quickly, right? So when we spread the wet clothes, evaporation becomes faster because surface area increases. There is another example. So water will evaporate from this bottle and from this tray. So from tray, the water evaporates quickly because area is more than this bottle. Next factor is circulation of air. Evaporation becomes faster when speed of air circulation is more. For example, wet clothes dry quickly if the wind is blowing. Then humidity. It is a measure of quantity of water vapors present in the air. When high humidity, the quantity of vapor in the air is more and evaporation is slower in damp air. So, what are effects of evaporation? What for cooling is produced when liquid is evaporated. Why? Because for evaporation, the heat from the surrounding is taken, causing cooling. Right? In summers, we perspire, we sweat a lot. So under the fan, we feel quite comfortable because the circulating air sweeps our perspiration and also takes the heat of the body. Then in our olden time, earthen pitchers, they were used because these were having fine pores through which the water seeps out and evaporates, taking the heat from the water inside, thereby making the water inside the pitcher cool. Then you can see here, then in high fever, doctor advises wet sponging because wet cloth uses the heat of the body to evaporate water from, so thus causing lowering of temperature. Then milk is poured in. If you have to drink milk, hot milk, you pour it into a saucer, the area will increase, so evaporation will be fast and it is easy to drink. In summers, we find cotton clothes very comfortable because cotton is a good absorber of sweat, so sweat evaporates, causes cooling. To show that evaporation causes cooling, so we take a thermometer and on its bulb we will wrap a cotton, wet cotton. So what will happen? When this water from the cotton evaporates, the temperature will lower down, and that we can note down in the thermometer. Next is fusion or melting. Fusion, these are the same processes. It is a process changing of state from state of liquid to solid on heating. So melting point is that temperature when the solid melts to become a liquid, as ice melts at 0 degrees Celsius. So what happens during melting? Particle level. What happens at particle level? The particles of solid, they are quite close, and on heating their kinetic energy increases, they move away from each other, their bonds weaken, and this is they change into liquid state. And if you there is one experiment also to prove the melting point, that describes the process of melting. For this, we take some ice cubes in the beaker, set a thermometer with the stand and start heating the beaker. Until the whole ice melts, the temperature remains 0 degree. It will not increase even if you are heating the beaker. The reason being that this additional heat is known as a latent heat of fusion, which is only used to change the state from solid to liquid, but it does not increase the temperature. So melting point of different solids is different. Next process is sublimation. Sublimation is the process in which substance changes from solid to gaseous directly without changing into liquid state. So it is not present in all the solids but only in few of the solids like iodine, camphor, dry ice, naphthalene, ammonium chloride, because they have interparticle forces comparatively weaker than other solids. So they easily break their bonds and change into gaseous state. So this is an experiment to prove the phenomenon of sublimation, in which we take naphthalene balls in a china dish and we invert a funnel over it and cover its mouth with cotton and start heating. What will happen? Naphthalene change into vapors and got deposited on the cooler parts of the funnel. So this proves sublimation. Next is condensation, the process of changing of gaseous state into liquid state. And at particle level, when the particles of the gas are cooled, they lose their kinetic energy, they come closer and change into liquid state. Heat is given out to the surrounding by a substance during condensation. Next is freezing, the process in which liquid state of a substance change into solid state on cooling. And for example, in case of water, it is 0 degrees Celsius. And freezing point is the temperature at which a liquid solidifies at standard. So at particle level, what happens? The particle of liquid, they are far away, and on cooling they lose their kinetic energy and their attractive forces become more strong. The particle come closer and change into solid state. Wax contracts on heating, but water expands on heating. That is anomalous behavior of water that we discuss in later chapters. Then next process is deposition. It is the reverse of sublimation. In this process, change of vapors directly on cooling into solid without changing into liquid state. And it occurs in the same substances where sublimation occurs. It is reverse of sublimation. So ammonium chloride, dry ice, naphthalene. And there is one experiment to prove it. And it is the same experiment that the vapors that are formed from this, they get deposited on the cooler side and they can be scratched in the form of solid later. So this is all about the chapter. My dear students, I hope you better understood it and try to revise it. Thank you so much.